So welcome to the third workshop in the summer semester titled Bash Basics. I'm your instructor, Adam K., and we'll be going over hands-on using Linux. If you have your Kali VM set up from the previous workshop, please spin it up right now. We will be using them a lot throughout this workshop. So just a bit of what we're going to be doing. We're going to have introduction and setup of the CLI. I'll quickly explain what the CLI is and how you can set up for the workshop. Next is the file system. I'll go over how you can navigate the Linux file system, some basic commands, and also file and directory manipulation. We'll also go some system commands. I do have also a tutor program which you can learn more commands, and I have also prepared an audit CTF where you can use the Linux commands that you learned today to find some flags in your system. And finally, I'll go over some resources which you can do and learn more. So let's get started. In your Kali VM, you want to run this command. I'll copy and paste it real quick. This is a curl bash. So normally you do want to avoid running random random shell commands, but if you look over here, it is it is really just pulling the workshop and it's compiling the Rust CTF. So that's what this program is doing. I'll go over here to my Kali machine. And what I will do is I'll paste this exact command, and it's going to take some time. It does require sudo because you need to install Rust if you don't have it already, and that's going to take some time. So in the meantime, we'll be going over is what is a CLI. Short, it stands for the command line interface. It is using text to communicate with your computer. The CLI is just one method of accessing the shell. In an operating system, the shell is what bridges the user and the kernel. The kernel controls directly the hardware, and different utilities can be run through the shell. Bash is the born again shell. This is just one of the shells that can be used to access the kernel. It is the default on most Linux distros, which is why you should use it. It is POSIX compliant technically, but it does have additional non-POSIX features which are called bashisms. So what is POSIX compliant? POSIX is a standard defining operating systems. It is meant to be universal, so if your program is POSIX compliant, it is guaranteed to work on many different systems, even if it's not the exact same operating system. Some of the bashisms included are tab completion and functions. Those aren't included in the POSIX standard. And as you'll find out in future workshops, Bash is also a scripting language. You can use it to run commands, have functions, and much more. And learning Bash will make you a hacker like inside this GIF. So going back over here to our Kali machine, we're still building the Rust program. This is really just the CTF part, but we do have the tutor program, so we can start that right now. And so what did I do right here? What I did is some navigation, and here are some of the key concepts and commands which you'll be using pretty much every day when you're using Bash. The first command everyone should know is pwd. It stands for print working directory, and this command shows you exactly where you are in your file system. And you just run by typing pwd in the terminal. And in here, this is the directory that I am in. If I want to, say, be in a different directory, I could do cd, which stands for change directory. However, I don't know what directories are here, so what we can do is we can run ls. What this does is it lists the stuff inside your current directory. You can also list files in other directories. So for example here, what we could do is type in ls, and what this does is it shows all of the files inside our current working directory. There are some other options we can have, such as ls-a, and it shows all of the files inside our directory, including hidden files. And another flag, which is what this -l is. This is -l is a flag which modifies the output of the command. What this does is it gives us more metadata and information about the different files that we have. So for example, what we could do is we can cd into, for example, tutor modules, and then if we ls, you could see that we have a bunch of different files in here. You can also cd dot dot. What dot dot is the previous directory, and we'll go over absolute and relative paths about right now. Absolute paths are when you list paths which go directly through the root. You reference the root. So for example, /home, /user, and so on and so forth. What we could do is we could, for example, cd /home/red, and this goes to our home directory. We could also cd /home/red/desktop, and that's going to cd us into the desktop directory. However, you can see that this adds quite a lot of characters really quick. So the other option we have is relative paths, and what this does is it starts from your current working directory. Dot in bash is your current working directory, and dot dot, like I mentioned before, is the previous directory. So you can go both forwards and backwards. How this works is we can cd dot dot dot, and this goes from desktop to home, and cd dot slash, for example, bash workshop is going to go to the bash workshop. Relative paths can help save time since you don't have to type out the full path, but they may be a bit confusing, which is why we also have the option of absolute paths. And finally is the home directory. Every user on the machine has their own home. For root, the root user has their home in /root, and each non-root user has their home in /home/user. And tilde is synonymous with your home directory. And if you could see here, we can cd if we don't pass in any options. It's going to change our current directory to tilde, which is our home. So we can also do cd tilde/bash workshop, and technically this is an absolute path since tilde is replaced with /home/red in my case. For you, you may have a different user, so this might be different. And if you were root, it would be this. It would be /root. So this is the basics of navigating through the Linux file system. The Linux file system is a tree. There's a single root node, which is called root, and you can have multiple files and folders. In addition to navigating, we can also do different commands with files. For example, the touch command, it creates an empty file. If we run that over here, we can touch hi.md, and if we ls, we now have the file hi.md. This creates an empty file. There is nothing inside. If we looked at it in an editor, we wouldn't see anything in there. Additionally, if you want to make a folder, you run the command make dir, and in Linux, directory is basically the same thing as a folder. Think of all whenever someone says directory, just think folder. And you would just run the make dir command. So we could do make dir notes. And if we run ls, we'll see we now have the notes directory. If we look at it in ls-l, we see that hi.md has rw. So these are just permissions. And this first bit here, this is a dash, which means this is a regular file. For notes, this is a directory. So has the D at the beginning, which signifies this is a directory file. Basically everything in Linux or Unix type operating systems, basically everything is a file. All of your program files, your images, directories, all your programs, even certain devices are files stored inside your operating system. There's other commands you can run, such as cp, mv, and rm. cp stands for copy file, and what this does is it duplicates your file to a different path. So for example, in your file explorer, you'd copy and paste. cp would be the copy. mv moves your actual file. This would be cut and paste. It would take your old file and it would move it to the new file path. And rm, well, it just removes your file totally. You can also add these files recursively. So you would add the fr, and a very famous rm command would be sudo rm-fr/. And this is a very dangerous program. I would not run it on your system if you love it, or if you have any important stuff on there. What it does is it removes everything inside your root directory, which is basically everything on your system. So I spoiled the surprise for some of you, and hopefully you never run this command seriously. So what we can do if we want to cp hi.md to hi.text, if we look at the directory again, we now have two files. But if we wanted to move hi.text to hi2.text, what we would see is that the regular hi.text has been replaced by hi2.text, and it's nowhere to be found. And if we wanted to remove hi2, we could run rm hi2.text, and if we look at our directory, we don't have hi2 anymore. We have some other important file commands. We have head, cat, and tail. This is basically if you want to read a file. We have a beautiful infographic here demonstrating how to use the Linux terminal. Head, what this does is it grabs the beginning of a file, and you can specify the amount of lines with -n. Cat reads your entire file to standard out, which is basically your terminal. There's three types of devices: standard in, which is your input; standard out, which is your output, which is your terminal; and standard error, which typically also is your terminal. Tail, it grabs the end of a file, or the end of a cat. -n specifies the number of lines, and -f follows the end. So if you have a file that changes constantly, such as a log file, -f would constantly keep updating, and it would add the new lines as it goes on. In Linux, we also have links. They can be soft links or symbolic links, or they could be hard links. A soft link is basically like a Windows shortcut. You can basically have like a link, and when you click it, it would run a program inside a different directory. So for example, in your desktop, you could have a shortcut to your browser, and that would be a symbolic link in Linux. One problem with symbolic links is that they break when your source is moved, and you can make a symbolic link using ln-s for specifying the source, or what is the file you want to be linked, and then afterwards you specify the place where you want the link to be. You can also create a hard link. This would be basically a second name for a file. And how it does that is it uses the same inode. An inode is basically how the operating system tells what is the file. Each file has a unique inode except for hard links, which have the same inode. And it would have the exact same size as the linked file. And to make a hard link, you would run ln without the -s flag. And you would specify first the source and then the link. Inside the terminal, I hope everyone has their entire program installed. You want to make sure you have bash-workshop on your system, and what you can do is first run cd /bash workshop or just bash workshop. And then afterwards you can run /tutor.sh. What this is a shell script. So like I mentioned before, bash is also a scripting language. We can also cat this out, and you can see that this is a file, or a text file to be specific, and you can see that this does some stuff. But we can also run this, since if we run ls-l, this is going to show that it has the execute privilege, which means we can run this as a program. What we do is we specify /tutor.sh, and this would run the tutor program. So the CC stands for Control C. This is how some programmers like to specify it instead of typing out the whole control. And like I said, in Unix, everything is a file: your text, your images, your videos, your programs, and your directories. And the first command that the tutor goes through is the SSH. SSHing is very useful inside cybersecurity. We SSH into different machines. For example, Hack the Box allows you to SSH. And right now, this interactive demo is asking us to type in SSH user at 192.168.1.1. And the structure of this is SSH is the command, and afterwards we have the argument, which is the user, and then at the IP address. So if we press enter, it's going to take some time, and it's going to give us a shell inside that machine. Obviously, this is a simulation of an actual SSH, but that's just the gist. Now that we're inside the system, you can also know where you are using the pwd command. And in our case, that is our current directory. To see what is inside here, you can use ls to see what is inside the directory. And ls-l shows you more metadata, which is your permissions, who owns the file, and what the size is and the time it was last modified. So if we run ls-l, it's going to show us the entire directory. But just pwd and ls isn't enough. We also need to move around our system, which is why we use cd. And this first cd example is an example of a relative path. And the next time we get our shell prompt, we're going to see that we are in logsweb. And the absolute command would be cd/home/bash-workshop/tutor/logs/web/apache. This is a bit to type out. In a normal bash shell, you would have what's called tab completion, where you can press tab and your shell is going to automatically guess what to run. Since this is just a pseudo shell, we don't have that capability implemented yet, so you do have to type it all out, but I assure you it can be much faster. And then cd, what this does is it moves you back to your home directory. Does anyone have any questions on the interactive demo on the tutor program? If not, I'll continue on hidden files. Hidden files are files that start with dot. In our case, inside this directory, we have .secretnotes.txt. This is a hidden file because it starts with the dot. We also have the file dot, which is our current directory, and double dot, which is the previous directory. And if we cat out the secret file, we can see that it is like our other file. You can also use head and tail to look through a log file. And you can also run tail-f, which is interactive. If we try to cat out web.log, you can see that it is very big. And with big enough files, it's going to fill your entire screen and you'll have to scroll through your terminal. So which is why we can also use head-n5 web.log. This is going to give us just the first, but this is an incorrect command. We have to type out the exact command, which in this case is tail-f web.log. And we waited a bit too long, but it would add new lines afterwards. And you can press Control C, and that's going to stop reading the file. I guess I'll stop just going over through the tutor, since you can also go through it here. Some resources if you want to learn more of Linux and just bash. Here are some CLI resources which you can use inside your actual terminal. First is the man pages. These are the most well-known documentation, and this is basically your standardized help menu. It describes what the program does, all of the options, and what they do. It can be a bit verbose for beginners, so watch out for that. And an example would be man Go. Go is a programming language for those of you who don't know. And I can show you an example of the man pages right here. So if I Control L and clear my screen, we can, for example, man apt, and apt is a program which is a package manager. And you can see here, this is our man page. It gives you a lot of information. There's a lot to go through, which is why it can be intimidating for most people. But some key areas are this short description, where you can see all the different options which you can specify. And then the options, which is where you can have flags, such as apt-h shows the help menu, and -v shows a program version. These are very standardized, and And this is our man page. So if we man apt, it's going to show us the man page. There's a lot to go through, and you shouldn't be reading all of it. The main place where your eyes should go are this description. This describes the command, and here are some of the options that you could run. And then the options, which are the flags. You can press Q to quit the man application. And we'll skip over TLDR pages, and the third resource is the -help flag. Most programs have a --help, and it can follow other formats as well. It could be -h, or you could specify directly help without the flag. These are always made by the programmer, and it details basically the simple usage of the program. An example of this would be git --help. And what this does is it just shows a short usage guide of using Git. We can also do ls-help, and this gives us the official documentation for the ls command. This is a lot. There is another program which is called less. You can do ls-help, and we can pipe it into less, and what this is going to do is it's going to take the output and allow us to scroll through. So we can start at the top, and we can scroll down, and then to exit, we press Q. And we also have the TLDR pages. These are community source pages, which means that basically it's not the programmer responsible or the operating system. It's just a bunch of people coming together trying to make a good resource. And the TLDR of it is that it's basically a short and simple version of a man page. It doesn't show all of the bloat. It really just is a short description and your most common flags and examples. So if you want to install the TLDR, you can do apt search TLDR. And in our case, we have TLDR. And then if we want to install it, we can run sudo apt install TLDR. And to run this, you can run TLDR git. You do need to run the update command. And what this does is it takes the remote cache pages and it downloads them and it updates it on your local end. So once you have the cache, you don't have to use the internet, just like with the man pages. So if we take a look at man git, this is one of the largest man pages out there. But if we do TLDR git, it is much simpler. It tells us what it is and some different commands you can run and some options, and it details everything. These are much easier to read through. I highly recommend, if you're starting out, try to install the TLDR pages. Additionally, we have some web resources here. This GitHub repo links to a bunch of useful resources to learn Bash specifically. There's books, there's command line. One common thing is the Bash pitfalls, which is the common places where people get stuck and how you can avoid them. There's also customization for Bash, and yeah, I highly recommend going over some of these resources as well. We also have Linux Vox and Geeks for Geeks. These also are great resources if you want to learn Linux or if you want to learn the Bash shell. Anyways, I guess it's time to share the CTF challenge. So by now, it should be installed by now, your CTF. So what you would do is you want to cd into the bash workshop /CTF. And this is a Rust project. Please don't look at the source code, but you can also cd into challenges. And here you have a bunch of different tasks to complete. And once you find the flags, you can run verify. Then you can wrap it inside quotes. And it would follow the format flag, blah, blah, blah. And in this case, it's an incorrect format, and this is what your flag should look like. So the first flag is really intended to get you to use some of the first commands that you learned. First is ls. Whenever you're in a directory, you want to run this to see what is inside. And we see here some interesting files: suspicious bin, encoded text, and readme. Does anyone know how we can read one of these files? Well, we can start with reading the readme.txt file. So how we do that is we can do cat readme.txt. And in this case, we got one of the first flags. You can't copy this exact flag. You do have to run it on your own machine. And if you want to actually submit it, you would run verify, and then you would Control-Shift-V and paste the flag, wrap it around single quotes. Do not wrap it around in double quotes. I'll show you why that is the case. That would be an invalid flag. Huh. 10 out of 14 flags. So as you can see, the CTF, it tracks your progress when you submit a flag. I already have found this flag, so the counter does not go up. But what else can we do inside here? One thing that could be an issue, we can also run ls-al. This is going to list everything, and it's also going to list all of the metadata. So here we can see a couple of things that are interesting. First is the hidden credentials.txt file, which is a futile attempt to try to hide a file. As you can see, we can cat.hiddencredentials.txt, and this is going to give us our hidden flag. Inside the terminal, you do want to run Control-Shift-C. That copies your selection to the clipboard. And then I run verify, single quote, Control-Shift-V to paste in the flag, and with a single quote, and enter. That is how you find the second flag. Additionally, instead, if you don't want to just read the output of a file, you can also run vim readme.txt, and this is going to open a file editor called vim. And vim is recommended for advanced users because of the many different options it has. It looks simple, but there is a big learning curve. Even I don't know everything inside vim, but I know you can, for example, copy that to the clipboard. Then we can paste. For example, you can paste 6 times, and it's going to paste that. And then if you want to exit, you can type in, first you want to escape, you want to be in normal mode, then you want to press a colon, and then Q an exclamation mark, and that's how you exit Vim. Again, to solve some of these challenges, you do have to run some commands that we haven't gone over. So please go over the tutor program. Basically anything there is, I would say, fair game. There's one program which might be a bit difficult since we haven't gone over the actual command, but I'll give you a short hint. You can use another program. You don't have to use the command line. If you do, props to you, but if you don't, that's alright too. Other than that, thank you so much for watching this presentation. If no one has any questions, I guess that's it for the official workshop.